when you look at the actual internal design of a bomb, and it's just so damn clever and neat, and to think that with that you can lift 1 million tons of rock into the sky.
Scientists have always pushed the boundaries of discovery, but sometimes their experiments have come dangerously close to unleashing global catastrophe. From the potential to ignite our atmosphere to creating man-made black holes, some of these experiments were a risky game with fate. Buckle up as we dive into the terrifying experiments that could have ended the world. The Kola Superdeep Borehole, humanity's descent into the unknown. The Cold War was a time of fierce rivalry, with the United States and the Soviet Union vying for supremacy in every conceivable domain. While America reached for the stars with the Apollo program, the Soviets decided to dig into the very fabric of our planet. Their ambitious scientific endeavor, the Kola Superdeep Borehole, became an iconic project that probed Earth's crust like never before. Started in 1970, the borehole wasn't just a scientific experiment, it was a bold statement of Soviet ingenuity. Reaching a staggering depth of 40,230 feet, it remains the deepest man-made structure in history. For perspective, Mount Everest would disappear entirely if placed inside the hole, and you'd still have room for another mountain or two. But this was no smooth excavation. Drilling into the Earth's crust at such depths revealed unexpected challenges. Scientists encountered rock-crushing temperatures of 356 degrees Fahrenheit, 180 degrees Celsius, far hotter than they had predicted. It was as if the Earth itself was saying, "Not so fast." These extreme conditions ultimately forced the project to halt in 1989, well short of the initial goal. The fears surrounding the drilling were just as intense as the heat below. Many worried the ambitious project might trigger catastrophic events. Would it destabilize tectonic plates? Could it cause earthquakes or fissures? The predictions sounded like the plot of a disaster movie. Yet, when the drilling stopped, the Earth remained stubbornly intact, proving that human curiosity, while bold, had limits in the face of natural resilience. Despite these challenges, the Kola borehole offered valuable scientific rewards. Fossils of plankton, buried for over 2 billion years, were discovered. Tiny remnants of life preserved in the Earth's oldest rocks. These findings gave researchers new insights into the planet's history, proving that the journey wasn't just a futile exercise in digging. If the space race was about conquering the cosmos, the Kola borehole was a battle with Earth itself. The Soviet subterranean venture may not have reshaped geopolitics, but it showcased humanity's relentless drive to push boundaries, whether reaching for the stars or plumbing the depths of our world. And really, who knew digging a hole could make history? The tale of Starfish Prime. In the summer of 1962, the United States took the arms race to new heights, literally. As part of the Cold War frenzy, they detonated a hydrogen bomb, not on Earth, but 250 miles above the Pacific Ocean. The result? A celestial firework display that no 4th of July celebration could ever top, and hopefully never will. This wasn't just any explosion. It was a test called Starfish Prime, a bizarre blend of scientific curiosity and Cold War brinkmanship. To grasp the magnitude of this experiment, imagine this. The bomb packed a punch 100 times stronger than the one that obliterated Hiroshima. That's like comparing a firecracker to a raging volcano. The stakes couldn't have been higher. Scientists were both excited and terrified. What if this detonation fried Earth's magnetosphere, the invisible shield protecting us from deadly solar winds? Would it leave our planet sizzling under increased radiation? The possibilities were as thrilling as they were horrifying. But why blow up a bomb in space at all? The Cold War wasn't just about stockpiling nukes. It was about showing off. As the space race heated up, the United States flirted with the idea of a potential space war. Testing a nuclear weapon in orbit wasn't just an experiment, it was a message. We're ready to fight, even in the stars. The detonation itself was a spectacle. The night sky lit up with a burst of colors, creating an artificial aurora visible from thousands of miles away. But the after effects were less entertaining. Satellites, the cutting-edge technology of the time, were fried by the radiation. Communications were disrupted, and the Earth's orbit carried traces of this radioactive chaos for years. While the world didn't erupt into flames or become a giant microwave, the experiment left scientists scratching their heads and wiping their brows. Was it worth the risk? The magnetosphere survived, but barely, and the event served as a stark reminder of humanity's ability to wreak havoc even beyond Earth's atmosphere. Could greenhouse gases save us from aliens? Reducing greenhouse gas emissions might not just save our planet, it might save us from an alien invasion, or so some scientists theorize. Back in 2020, the US Defense Department released jaw-dropping Navy videos of unidentified flying objects. These UFOs zipped through the skies at hypersonic speeds, over 3,800 miles per hour, only to shift direction instantly, defying the capabilities of human technology. And while the government stopped short of calling it alien activity, the unsettling mystery has left many wondering. Enter SETI, NASA's search for extraterrestrial intelligence. For 6 decades, this team has aimed radio telescopes at the cosmos, listening for signals from advanced civilizations on distant planets. Despite their tireless eavesdropping, the universe has been eerily silent. But some scientists are tired of waiting for a cosmic hello and are advocating for METI messaging extraterrestrial intelligence. Their bold plan? Instead of waiting, beam powerful messages directly into space, hoping to provoke a response. It sounds ambitious, or perhaps reckless. Imagine sending text messages to interstellar beings without knowing if they're peace-loving philosophers or war-hardened conquerors. The lack of regulations on such off-world communication adds another layer of chaos. Anyone with access to high-powered transmission tech can send anything, from interstellar insults to declarations of war. Sure, a "your mom" joke might seem harmless to us, but to a hyper-advanced alien species? It could be taken as a reason to retaliate. And here's the kicker. If those UFOs are indeed alien crafts, their technology is light years ahead of ours. They could reduce our defenses to rubble before we even realize we've offended them. The very idea is both thrilling and terrifying. So, is it worth risking our species' safety for the sake of curiosity? While media enthusiasts might argue that boldness is necessary, others suggest we keep quiet and focus on fixing Earth's problems, starting with greenhouse gases. After all, a cleaner planet is something we can control, unlike the hypothetical wrath of extraterrestrial beings with superior tech. Manhattan Project. In December 1942, beneath the stands of Stagg Field at the University of Chicago, history witnessed the unimaginable, the first controlled, self-sustaining nuclear chain reaction. Imagine harnessing the power of the atom, a force capable of immense destruction and untold potential, in a laboratory setting. Led by Enrico Fermi and his team, this experiment was part of the Manhattan Project, a secretive, all-out effort to create a weapon that could potentially end World War II. This moment was the spark that would ignite a revolution in warfare and global politics. Fast forward less than 3 years, and the fruits of this scientific gamble were unveiled in the arid deserts of New Mexico. On July 16, 1945, the Trinity test illuminated the sky, releasing an energy equivalent to about 20,000 tons of TNT. To put that into perspective, that's like detonating 20,000 traditional bombs in a single instant. Originally intended to counter Nazi Germany, the timing of the war in Europe rendered the bomb's purpose ambiguous. Yet, its potential use in the Pacific Theater was chillingly clear. And so, on August 6 and 9, 1945, the cities of Hiroshima and Nagasaki bore the brunt of this devastating new technology. The combined force of these 2 bombs obliterated over 2 million lives, instantaneously altering the landscape of war and humanity's perception of power. Just days later, Japan surrendered, bringing an abrupt end to World War II. But peace came at a cost. The atomic bomb's creation marked the beginning of a new, shadowy conflict, the Cold War. By 1949, the Soviet Union had conducted its own atomic test, plunging the world into an arms race where each superpower tried to outbuild and outpower the other. It was a race not just for dominance, but for survival, with each bomb larger and deadlier than the last. A sobering reminder of what humanity had unlocked beneath the University of Chicago just 7 years earlier. The Trinity Test. The Trinity Test, conducted on July 16, 1945 in the New Mexico desert, was the world's first nuclear test and a milestone in the Manhattan Project. This collaborative effort by American and British scientists aimed to create a weapon so destructive that it would deter enemies like the Nazis and the Japanese. The test, marking the dawn of the nuclear age, was the first of 528 atmospheric and underwater nuclear weapon tests. Each of these, starting with Trinity, left lasting scars on the environment and nearby communities. While the idea of unleashing such power intrigued many scientists, not everyone was thrilled. Enrico Fermi, the Nobel Prize-winning physicist who had built the first nuclear reactor, had serious reservations. He and some of his colleagues worried about a chilling possibility. What if the explosion triggered a runaway fusion reaction that would ignite Earth's atmosphere? Imagine a single test wiping out all life on the planet. Their hypothesis turned out to be wrong, but it added a dramatic layer of uncertainty to an already high-stakes experiment. According to Business Insider, the first atomic bomb ever created was named Gadget. It was a big metal sphere with a 6-foot diameter, a mess of wires spilling over its surface, and a ball of plutonium the size of a grapefruit lovingly nestled inside. This was the first tested prototype of the infamous Manhattan Project, the United States' answer to Albert Einstein's warnings that the Nazis were tinkering with their own doomsday device. Gadget was completed in 1945 and detonated on July 16th at precisely 5:29 a.m. The 22-kiloton bomb exploded, illuminating the desert with an eerie brilliance. The blast proved the bomb's devastating power and reassured the team that Earth's atmosphere wasn't about to turn into a cosmic bonfire. Yet moving forward with such a gamble, even after Fermi's warning, was a staggering display of human audacity, or recklessness, depending on your perspective. The Trinity test may not have destroyed the planet, but it did usher in an era of nuclear experimentation where humanity grossly underestimated the dangers of its new toys. By the 1950s, nations worldwide were detonating nuclear weapons in various environments, on land, underwater, and even in the upper atmosphere. The grim irony? Soldiers and civilians in the vicinity of these tests were often left unprotected, exposed to the invisible dangers of radiation. The contrast between the initial caution of the Trinity test and the casual attitude toward subsequent nuclear experiments is striking. Early fears of planetary destruction were replaced by a cavalier approach to testing, leaving a trail of environmental degradation and health crises in its wake. Fermi's warnings may have been off the mark, but they serve as a reminder of the razor-thin line between scientific progress and catastrophic risk. Large Hadron Collider, LHC. Imagine a machine so powerful it could unlock the secrets of the universe, or so some fear, destroy it. Meet the Large Hadron Collider, LHC, a particle accelerator housed in a colossal 27-kilometer ring beneath the Franco-Swiss border. While sensationalists might shudder at the thought of it creating a world-ending black hole, scientists chuckle and confidently reassure, if the LHC does spawn black holes, they'd be subatomic and vanish faster than you can say quantum physics. The LHC is a high-stakes gamble, a $4.75 billion scientific marvel designed to smash particles at near-light speeds. The risks? Substantial. There's the potential for dead ends, failure to find new particles, missed opportunities to validate theories, or worst case, catastrophic equipment failure. But the rewards? They're astronomical. Imagine peering into extra dimensions or uncovering dark matter, the elusive glue holding galaxies together. These possibilities make the risks seem like a pothole on the autobahn of discovery. Speaking of dimensions, most of us live comfortably with 4, 3 spatial and 1 temporal. But the LHC could reveal at least one more, a hidden spatial dimension lurking beyond our perception, detectable only at energies millions of times greater than your toaster's output. Think of our universe as a two-dimensional painting, with the LHC offering the chance to peek at the three-dimensional sculpture it's painted on. Mind-bending, isn't it? As for dark matter, it's the ghost of the cosmos, unseen, untouchable, yet outweighing visible matter 5-1. Confirming its existence via the LHC would revolutionize physics more dramatically than Einstein's relativity. Throw in tantalizing hints at phenomena like time travel, yes, time travel, and the LHC becomes less an experiment and more an intergalactic treasure map. Are we really ready to say hello to aliens? The search for extraterrestrial intelligence, SETI, is humanity's bold and ambitious attempt to find out if we're truly alone in the universe, or if the neighbors have been eavesdropping all along. It's like throwing a cosmic message in a bottle into the vast ocean of space, hoping for a response. But as thrilling as the prospect of contact might be, some skeptics argue, should we really be waving at the unknown? After all, first impressions matter, and who knows if the extraterrestrial equivalent of Martians would appreciate Earth's quirks. SETI, launched decades ago, has evolved into a global scientific project pooling activities, organizations, and brilliant minds. Its mission: to detect signs of intelligent life beyond Earth. Unlike Hollywood's depiction of flashy UFOs descending on unsuspecting metropolises, SETI's approach is far more subtle, analyzing faint signals, radio waves, and even our planet's own digital footprint to spot a sign of cosmic company. What's fascinating is how Earth's radio signature has become a mirror of human progress. For instance, data modeled by Ramiro Saide, a talented intern at SETI's Hat Creek Radio Observatory and a student at the University of Mauritius, shows that developing countries, particularly in Africa, are contributing significantly to this signature. By skipping the clunky landline era and embracing mobile technology, these nations have showcased a tech leap that's nothing short of awe-inspiring. It's as if Earth's collective voice is harmonizing with a global symphony of progress. But wait, there's more to this digital cacophony. The research team plans to expand their scope, analyzing other contributors to our planetary chatter. From civilian and military radars to Elon Musk's Starlink satellites beaming down the internet from space, our planet is practically screaming, "Look at me," at the cosmos. While SETI experiments pose no immediate threat, one can't help but wonder, are we broadcasting a welcoming handshake or an accidental dare to the unknown? Weaponizing the plague. The previous time the plague spread, it killed over half of Europe's population, reducing the world's population by nearly 100 million in the 13th and 14th centuries. In the late 1980s, the Soviet Union's Biological Warfare Research Department discovered how to employ the plague as a weapon, which could be delivered at foes in missile warheads. What might go wrong? Aside from the plague, defectors disclosed that the Soviet bioweapons program contained hundreds of tons of anthrax and smallpox. Back in 1989, the director of the Soviet All-Union Institute of Ultra-Pure Biological Preparations, Vladimir Pasechnik, was on a business trip to France. He used a phone booth in Paris to call the British embassy and offered to defect. The insight he provided about the Soviet Union's biological warfare program helped the rest of the world realize that they were far more ambitious than the West had anticipated. This was clear from the time he began discussing the infections he was most familiar with, such as Yersinia pestis, the agent that causes the plague. Pasechnik told the British that tremendous attention had been placed on perfecting pneumonic plague as a warfare agent through optimization of its manufacture, storage, aerosol spread, and antibiotic resistance. Pasechnik's job at his institute in Leningrad was to devise methods for preparing and manufacturing diseases so that they could be weaponized without losing effectiveness or virulence. One of the most disturbing revelations he discovered was that the Soviet military had already weaponized disease, putting it into a warhead that needed to be reloaded every several months. To generate enough agent, the industrial capacity was increased to 2 metric tons per year. He admitted that they had tested the plague agent on baboons on Vozrojdenie Island in the Aral Sea. Following months of negotiations in late 1990, The first US and British specialists surreptitiously traveled to the Soviet Union in January 1991. The Western specialists left with their concerns only heightened. We now know that the Soviets made every effort during the visit to conceal the biological weapons program at many dubious sites. The experts wrote in their report that the sheer size and scope of the program, the configuration of the facilities, the nature and extent of the pathogen research, the guards and physical security, and the large aerosol chambers for experiments all pointed to an offensive biological weapons program far beyond what might be required for civilian use. Pasechnik, who died of a stroke in Wiltshire, England in November 2001, had broken down the barriers and shifted the focus to the Soviet effort. However, quiet diplomacy proved to be of limited impact. The Soviet Union disintegrated without ever confessing its treaty transgressions or the truth about biopreparat. President Boris Yeltsin told Bush in 1992 that he would end the program, but questions remained that Russia had done so. In the 1990s, important Soviet germ warfare sites, such as the anthrax factory in Stepnogorsk, Kazakhstan, were uncovered and demolished. During the same decade, Russia opened some of its institutes in biopreparation for international cooperation and conversion to civilian applications. Operation Cirrus. Few forces of nature can match the sheer ferocity of a hurricane or tsunami. Imagine winds howling at over 150 miles per hour, leveling entire cities in hours, or towering waves swallowing coastlines like a hungry leviathan. It's a deadly game, and humanity, being the audacious species we are, decided to try and outsmart Mother Nature. Enter Operation Storm Fury, a daring 20th century experiment to steer hurricanes by seeding them with dry ice. Picture a scientist saying, "Let's sprinkle this storm with 180 pounds of frozen carbon dioxide and see what happens." The hope: redirect hurricanes away from cities, saving countless lives. The reality? Let's just say nature had other plans and they weren't pretty. The roots of this audacious idea trace back to Project Cirrus, a collaboration of heavyweights like General Electric, the US Air Force, and the Navy. The plan sounded deceptively simple. Toss dry ice into a hurricane's cloud deck to disrupt its structure. Early results showed promise. Cloud patterns visibly changed. But the storm didn't get the memo. Instead of turning away, it barreled straight into Savannah, Georgia, causing destruction and a tragic fatality. Cue public outrage and a collective, "What were they thinking?" It's like trying to train a tiger with a laser pointer. Ambitious, but probably not going to end well. Unsurprisingly, the project was swept under the rug for years, and efforts to control hurricanes largely fizzled out. Scientists discovered that these storms are staggeringly complex, more like chaotic symphonies than straightforward equations. And if hurricanes weren't enough of a challenge, during World War II, New Zealand and American researchers cooked up another wild scheme: tsunami bombs. Yes, the goal was to create artificial waves powerful enough to rival natural tsunamis. Thankfully, that idea never made it to prime time. Tsunami bomb. While the world was busy duking it out on battlefields and in the skies during World War II, New Zealand decided to pick a fight with the ocean. Yes, in 1944, while most nations focused on tanks, planes, and bombs, the Kiwis dreamt up something completely bananas: a tsunami bomb. Imagine weaponized waves, an underwater slap so massive it could drown entire islands. Crazy, right? But this wasn't a B-grade sci-fi movie. It was a real military experiment. The idea surfaced, pun intended, when U.S. Navy officer E.A. Gibson noticed that explosions used to clear coral reefs created small, oddly coordinated waves. This observation sparked Project SEAL, New Zealand's bold attempt to turn the ocean into its very own giant water cannon. Forget Godzilla rising from the depths. This was about unleashing the wrath of Poseidon himself on Japan. The stakes were high. Japan's leadership wasn't ready to throw in the towel, even as resources ran dry and blockades threatened mass starvation. The alternative? a full-scale invasion of the Japanese mainland with horrifyingly high casualty numbers on both sides. Meanwhile, the US was building the nuclear bomb, but New Zealand thought, why go nuclear when you can go nautical? Here's how it was supposed to work. By mapping underwater terrain, they'd set off a series of massive bombs in strategic spots to funnel water into a monstrous wave. The idea was to flood Japan with tsunamis from all sides, leaving no escape. Think of it as oceanic warfare meets extreme surfing. Testing began off Auckland's coast, where thousands of munitions were detonated. The results? A few stubborn ripples and some annoyed fish. It turns out water doesn't love being bossed around. It prefers its own flow. Still, New Zealand managed to create miniature tsunamis at Wangaparaoa in 1944 and 1945. When they spilled the beans to their ally, the US, the Pentagon couldn't help but lean in. America was already working on a bomb that could obliterate cities, so why not try one that could flood them too? Project SEAL sank before it could make a tidal impact. The water proved uncooperative, and with the nuclear bomb proving more explosive, the tsunami bomb was shelved. But imagine if it had worked. World history would have been rewritten, with tsunamis rolling alongside mushroom clouds. Perhaps it's just as well that the ocean has to keep its temper. Von Neumann. In 1948 to 1949, John von Neumann, a mathematician, physicist, computer scientist, and engineer with a resume that could humble even the sharpest minds, introduced the revolutionary concept of universal assemblers, self-replicating robots capable of constructing more of their kind. Fast forward to 1966, and his pioneering ideas were immortalized posthumously in the book Theory of Self-Reproducing Automata. Though conceived decades ago, von Neumann's vision has since inspired profound implications in fields like the search for extraterrestrial intelligence, SETI, with theorists speculating that if advanced civilizations exist, they've likely deployed such self-replicating probes across the cosmos. But here's the twist. What if von Neumann's vision was scaled down to microscopic proportions and placed inside your body? In 2023, scientists at New York University decided to give reality a pinch of sci-fi and unveiled nanomachines, tiny marvels operating at the nanoscale, small enough to interact directly with molecules and even DNA. Imagine machines so minuscule, 100 nanometers to be exact, that thousands could sit comfortably on the width of a human hair. The possibilities? Mind-blowing. For starters, these nanobots could revolutionize medicine. Instead of shelling out thousands for prescriptions, you could rely on self-replicating bots to manufacture the needed drugs inside your body. Think of it as upgrading your immune system with an on-demand pharmacy. But that's not all. They could repair tissues, serve as scaffolds for new cells, and speed up recovery. Picture breaking a bone and having it heal in a week instead of months. It's like upgrading from snail mail to broadband internet. And aging? Nanomachines might rewrite that narrative too. Since aging stems from DNA errors accumulating over time, what if we had nanobots to correct those errors with machine-like precision? You'd be halting aging in its tracks, at least until your nanobots catch malware and go rogue. Incredibly, NYU's DNA-based nanobots can replicate exponentially, with a single bot creating 2, then 4, then 8, and so on. Unlike older methods prone to errors during folding, these bots assemble 3D structures from scratch, raising the bar for precision. Von Neumann would be proud, and perhaps a little envious that his idea is now flourishing, not in space, but within us. Thanks for watching. See you in the next one.